Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at wireless media. We'll be discussing the properties of wireless media, the types of wireless media, and then finally we're going to have a discussion about wireless LANs. This episode is part of my series on Introduction to Networks. I'm Kevin here at KevTechify. Let's get this adventure started. Now, some of the properties here of wireless media. It's electromagnetic signals that we send through the air. Typically, they're radio waves, they're microwave frequencies that we send through the air. And we represent them, we encode bits on this. And once again, bits are what we're sending. As we work down through layer one, that's what we're sending. We're going to encode the bits through the air, either using radio frequencies or microwave frequencies. But there are some limitations here to our wireless signals. First limitation is the coverage area. There's only so far that radio signal can stretch before it becomes just noise. Once again, think of the example. You're talking to a friend and they start walking away. And the further they get away, the harder it is to hear them. And then finally, at some point, you're not going to be able to understand what they're saying. And so at that point, you either need to listen harder or have them yell more. You need to have them increase their signal. And they can walk away a little bit further, but then they'll get to a certain point again where you don't understand that. And so that same thing happens with wireless. Is you can get far enough away from that access point that you can understand it, but then you'll reach a certain point where there's interference or the signal just gets weaker and you can't understand the message being sent. You can't understand the ones and the zeros being sent across there. Wireless is very susceptible to interference, because think about that. We have all sorts of things causing interference. Some interferences come from common objects like microwaves. If for some reason the shielding on a microwave shifted a little and starts sending out a signal, it will interfere with your wireless signals in the 2.4 gigahertz range. That's the frequencies microwaves operate at. Looking at wireless phones, they operate in the 2.4 gigahertz range too. They'll cause interference. Machinery will generate electromagnetic interference, which will interfere any radio waves going through there. We have all these different issues. We have security issues we need to think about when we're looking at wireless media. Depending upon the different protocols you're using for security, some are easily compromised. If you're using WEP, well, please don't use that. That is easily crackable. We can download a version of Linux and run a cracking program, and I can tell you what your web password is in about 3 seconds. Very easy to do that. So make sure you're using the right protocols for security. It's also a shared medium, meaning multiple conversations can't happen at one time. Access point and one wireless client can communicate at a time. Now, normally it happens so fast between them, and we have some buffering that happens. It seems like people are simultaneously doing it, but only one person can communicate with the access point at a time. And so it's a shared medium. And the shared medium also, once again, refers to the shared frequencies, the 2.4 gigahertz, the 5 gigahertz. There's other things that can operate in those frequencies. And if you have any competing devices in those frequencies, it's going to interfere with you. Interference causes having to rebroadcast data and just slows down your final good put through your network. And so we have to look at that. Now, we do have several types of wireless media here. The IEEE and the telecommunications industries, they developed our standards for us. They went through and they did that. The physical layers here, they look at the data to signal encoding methods. How do we actually encode the signal on the radio waves going through there? Radio waves are little sound waves, compressions going through there. How do we encode information on there? We look at the different frequencies we can use and how strong that signal is. There's limitations on how much power you can pump through a wireless device. And so you have to work with those limitations of the power and the different frequencies. And so there's only limited frequencies you can use. And a lot of other people can use those frequencies. And you only can use so much power. That determines how far away from the access point you can actively communicate. What are the requirements for sending and receiving data? How do we know that we're getting ready to send that data? Also, how do we design our antennas in doing that? So we have to look at all of these different things here at the physical layer for our wireless communications. Now, we do have a number of different standards. We're probably most familiar with the Wi-Fi standard, the IEEE 802.11. And in there, we do have some substandards. Substandards are IEEE.11a, .11b, .11c, and looking at those standards. And typically, they get you faster and faster throughputs. Common ones we have are 802.11a, b, g, n, AC. AX is starting to be a new one out there. And these should be terms you think about when you go out and buy a wireless router for your home. What am I looking for? Am I looking for 802.11n or 802.11ac now seems to be the hot one out there. Pretty soon you're going to be looking for 802.11x. And those specifications determine how do we encode data on these frequencies in the processes to do that. Another standard we have here is the 802.15. That's Bluetooth. That's your personal network here. Bluetooth headphones to your smartphone, Bluetooth keyboard to your computer. That's the standard we're looking at. WiMAX is a internet delivery process, 802.16. That's how we look at delivering internet typically in rural areas. We call it the last mile of delivery, where they can build a tower and then they can feed a rural community with that. And WiMAX is one of the technologies we use there. Zigbee is another wireless protocol, 802.15.4. Zigbee is for home automation, where the devices in your house can communicate with each other. It's sort of like Google Home Assistant with Wi-Fi, but it's its own standard. And that way it doesn't interfere with the 802.11 standards. And so we do have several of these. Now, when you set up your wireless LAN, typically you need two components. You need one is your wireless access card. This is your NIC. This is your network interface card. Here I show you an example of one that can go inside of a desktop PC. It goes into a PCI slot. It has some antennas on the outside, so you can turn your desktop PC into a wireless computer. The second thing you need is an access point. This here happens to be an example of a Netgear access point. This access point sets you up and allows you to communicate back and forth. Normally, this access point, you have to have a wired connection into your network, and then that does the translation between your wired network and your wireless network. It was my pleasure to provide you with this wonderful episode on wireless media. If you like this episode and you got value out of it, and of course, depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.